Hi, I'm Ron Chaudhary, and in this video, I want to introduce the concept of a limit to you. In our last video, we were talking about the goals of calculus. A recap of that is the two main goals of calculus was basically how to find the slope of the curve at any given point, and how to find the area under a curve at any given point. In this video, I'm going to show you guys how to find the slope of a curve at any given point. So let's get started. So if I make a graph over here looking like that, and I have a point P and I have a point Q, and let's say I want to find the slope of point P. How would I do that? So before getting into how I'm going to do it, I'm going to introduce two different types of lines to you: a secant line and a tangent line. So a tangent line is basically the slope of the curve at the given point. So it's going to look something like this, where it doesn't look like it because I didn't draw it that well, but it is touching point P, but it's going on in the direction that point P is. So it is giving you the slope. It is the line, it's like the slope line of point P. Now, the secant line is much more simple, and it's basically when you connect the 2 points. So it's like when you connect point P and Q. So how are we going to use this in any way? We're trying to find the slope of P. We're technically already given the tangent line to solve for P, but why do we need a secant line? I'll explain it to you in just a second. So let me erase this for a second because we're not going to need it for now. Okay, so we're trying to find the slope of point P. Now, since we're trying to find the slope of point P, we're not going to move point P at all. What we're going to do, in fact, is we're going to start moving point Q closer and closer to P along this line itself until it's infinitely close. So if I were to start drawing the secant lines from here, because we already know what this one looks like, it would look something like this. And if you see, as I started moving point Q closer to point P, what's happening is that the secant line is starting to look more like the tangent line itself. So, with that in our minds, that's basically saying when point Q is moving to point P, the slope of the secant line is becoming the slope of the tangent line, which is a pretty interesting concept, and this is also kind of the concept of a matrix. If I put it more in a better version for you, we know that in order to find the slope of a line, you do change in y over change in x. If we just use a tangent line, we're only given 1 point, so we can actually not just use a tangent line and find the slope. With a secant line, we can actually find the slope because we have 2 points. But the thing is, we want it to be closest as possible. And since we need 2 points, if we keep moving Q closer to P, as close as possible to P, it can never be the same because then we can never find the slope. But it could be infinitely close to P, and we would have enough points to do change in y over change in x. So I'm gonna write an example up here now so that I hope you guys can understand it better. Okay. Let's fix our graph here a bit. So our example is going to be So we're going to have a graph of y is equal to x squared. And our graph is going to look something like this. We're going to try finding the slope at the point 1 and 1. So let's say this is 1, and this is 1, and this is going to be our point P at 1, 1. Which, by the way, would work, because if you do plug in the value of y is equal to 1, sorry, if you plug in x equals 1, it would end up being 1 and you get a y value of 1. So now we need a q value, a q. So we're going to have q up here. So what is our value of q actually going to be? Like the point? I'm not going to plug in any values specifically, but in general, it would be x comma y. But since we're given the value y is equal to x squared, we can change it to x squared, which would be easier for us in our way. So let's start off by doing the C. So let's just think about it. If we move q closer and closer to closer, it would give us a better approximation towards the tangent line of P, because as we discovered just a few minutes ago, as Q approaches P, the secant line becomes basically the tangent line. So let's use our change in y over change in x, which by the way is going to be x squared minus 1, x squared minus 1 divided by x minus 1. One value that you obviously can't use is the value of 1 because of the fact that it'll become undefined if I use 1. So why don't we factor this and make it a little simpler? And this is where algebra will actually help you. So it would be x plus 1, x minus 1, all divided by x minus 1. These two cancel out and you get x plus 1 for your slope of your secant line. So I said at the beginning that we're trying to find the slope for when it's at x equals 1. So if we do put x equals 1 over here, we're going to get a value of 2. Which is indeed this is what the slope is of the tangent line. Because as it approaches to 1, it becomes 2, which is going to be the slope. Now if we plug in all these points into the formula, y minus y1 equals m tan of x minus x1, we can actually find the equation of the tangent line, which is going to be y minus 1 is going to equal to 2, our value of m tan, which I should probably write here. M tan is equal to 2. And by the way, m stands for slope, if you guys didn't know. So 2 is going to be x minus x1, so x minus 1 again. And if we simplify this, y minus 1 is going to be we just found the equation for the tangent line of P. And that was basically what I wanted you guys to understand throughout the video. I wanted you guys to understand what secant lines and tangent lines were, which I hope you guys did understand, what limits were, and the equation of a tangent line. Thank you for watching my video. Please like and subscribe, and bye.